Hi everyone, welcome back to our channel. In today's video, we will be showing you how to automate meshing for the movement of a piston bowl and automatically generate multiple meshes which can be used to simulate the complex flow and combustion mechanisms in a piston bowl. This is completely done using GridPro's Python API. Before automating, however, we need to build the base blocking for a stationary piston bowl at a crank angle of 0 degrees with the bowl at top dead center. You can check out our video on how to create a blocking and mesh for a piston bowl here. There are several ways in which the mesh movement can be automated. 1. By moving the respective surfaces and corners in the topology and changing the density based on the change in length. 2. By moving the surfaces in the topology but allowing the density and hence total cell count to remain constant. 3. By extruding the faces of the generated grid. No modification in the topology. This video shows you how to proceed with the first method by moving the respective surfaces and corners in the topology and changing the density based on the change in length. Methodology. In this topology, 2D section shown here for clarity, the highlighted set of edges remain stationary, while the remaining corners move according to the crank angle. As the remaining corners move, the density of all the block edges along the z direction in the last layer needs to be changed according to the change in length. These are the actual corner and surface groups chosen for translation. You can see that apart from the corners assigned to the piston head and the surface itself, everything else in the topology translates. Extending the surfaces. Since we will be automating the movement of the piston bowl, there are some surfaces in the baseline topology whose length has to be extended to accommodate the stroke length. Namely, the liner surface and the internal surface created at the step of the piston bowl needs to be extended. Automation using API. Now we move on to automation. The automation is carried out via the script and consists of the following main steps. First, input the stroke of the piston and the number of grids to be generated between top dead center and bottom dead center. Crank angle of 0 to 180. 2. Translate all the surfaces and corners except the piston head and the corners assigned to it for each location, which is based on the number of grids. 3. Determine the change in edge length of one edge in the last block of the topology for a crank angle of 0 degrees and the current crank angle. And based on the change in edge length, automatically determine the new density and change the density of the last block layer. For example, let's say the length of the edge is L before translation and its density is 8. After translation, if the length becomes 5 times, that is 5L, then the density should be multiplied by 5 times. So the new density after translation is 40. The grid smoother is then instructed to run on the generated topologies and output the required grid files, which can then be used for CFD simulations. Salient features. The topologies for multiple stroke locations of the piston bowl can be generated automatically in a matter of a few minutes. The same script can be used for different engine configurations. GridPro also allows for the quick generation of a family of grids with different cell counts from the same topology. This aids in straightforward grid convergence studies. Thank you for watching. If you like this video, leave us a like and subscribe to the channel for new videos. If you have any questions or any comments, feel free to leave it below. Follow us on our social media pages. Links are posted in the description.